Let us welcome our guest speaker with a huge round of applause.
After the session, okay, thank you for that lovely welcome by the student. What's your name? Risha, and thank you to Bosco for having me for the session today. My name is Razia, as you can see. I'm faculty at Padre College of Engineering, and AI and ML are my passion domains. And I've been told that today we have commerce arts students as well, including the science students, which is really great because it doesn't really matter what degree you pursue or what you do. It is more about your passion. So data science and ML, if you are passionate about something, whether it is music or dancing or writing poems, whatever you're interested in doing, if you have output. And today technology has proven that it can give the best output. So whenever you have talks like this, you should attend, absorb as much as possible, because before being creative, you have to know what is available, what is not available, what is possible, what is not possible. And only when you know these things, then you can think more. So it's very important to keep an open mind and understand what is going on. And you have role models like Bill Gates and Steve Jobs, even Dhirubhai Ambani. They are all first generation entrepreneurs who made it big, irrespective of what background they came from, what was their degree. So it is just about knowing what is there, what is possible, and thinking differently and creatively. Okay, so with that little introduction, I would like to start. Before I go into what is digital transformation, I would like to show you all these apps, okay? And I would like to tell you, the first app, Instagram. How many of you use Instagram? Put up your hands. But you all are too young to use. Okay, anyway. Next, how many of you pay bills? I don't think, maybe you all pay for your parents and all. So bill payments. How many of you book, tickets to go by flight, train, to go for a movie online? All of you do this. Next slide. Have you all used Google Maps? Yes? No? Okay. So, yeah. So, those of you who have not used, good, you are too young to drive also, but you all can help others. What about Netflix? You all have used? No? Lies. This I'm sure you all have used. Next. Sir, previous slide. Healthify Me. Okay, this is, I think I have to install it. So Healthify Me is an app. Without going to the gym, I can get instructions how to become thin without going to a dietitian. So these are some apps. Now tell me very frankly, I think there was a slide with previous slides. Yeah, Swiggy also, okay? So how many of you really used Swiggy before the pandemic? Lies. How many of you started using Swiggy after the pandemic, during lockdown, started using? Okay. So basically all these ideas, all this creativity, it came into being during lockdown. Okay. So why did they come? They say necessity is the mother of all invention. So nobody was coming to buy a movie. So the movie industry was running dry. Then nobody was going to restaurants. Going out of the house to restaurants, they were running dry. So now the digital transformation brought all these things into our houses. And you can see this tremendous jump. The digital transformation was happening, there were apps, there were things, but now the demand was so high that exponentially the softwares and the people who were making softwares went on increasing. So this is the digital transformation. So digital transformation or DX, it is a term which is used to rethink business processes rather than tinkering with traditional methods. And I'll come to examples of digital transformation in the next slide. Using digital technologies, so the previous slide, using digital technologies to make business processes efficient and effective. If I'm not on Swiggy, the sales I make will be less compared to if I am on Swiggy. Netflix is not something new. Netflix has been there from the 90s. But they had about 5 million subscribers. When they shifted to digital transformation, now they have more than 100 million subscribers. So you can imagine the impact digital transformation has had. So this is some of the things you can see. The world's biggest retailer is Amazon. He sells so much without even having a shop. So he's basically taking from people's shops and delivering to your house. Airbnb, this is a place which gives restaurants on rent, without hotel rooms on rent. Without owning a single hotel, he gives you the rooms on rent. Similarly, we have Netflix. There are no theaters, but he owns no theaters, he owns no movies. He just buys the right to show them to you. Uber does not own any taxis. All the taxi owners are private owners. They are just connected by Uber. And Facebook. Facebook is generating the most amount of data every second of the day. Through your shares, through your likes, through your comments, whatever you do, Facebook is collecting data without uploading any data of its own. So this is the digital transformation which is taking place. Next we go to the pillars of digital transformation. So what do you require to have this digital transformation? So the first thing is you require a lot of data because you need to process that data. Now in order to process that data, you need technology. Take for example your Google Maps, for those who have used. You ask for a location and it shows you the place where you have to go. Correct? Well, I've used Google Maps, right? So you have to go to the place where you have to go. Now, can you imagine there is a satellite which is taking the image of that place? How big that image will be, so that when you zoom, you're inside the country, inside the state, inside the village, inside the street, on that street a building is being captured. So can you imagine how high definition that picture will be? And if one picture like that, of course the satellite is going round and round and continuously taking pictures. All these pictures, can you imagine how much data? I think even one photo would not, like Google Maps photo, would work on our phones with the memory which we have. But that is the power of the cloud. So there is a cloud where all the data is hosted and we can access it from the cloud. How many of you have used Gmail? How many of you have phones? In the past, if I sold my phone and I bought a new phone, I would have to transfer that data to my phone. Now all my data is on the cloud. I don't need to invest in buying an expensive phone which has high memory, because I can store my data on the cloud. So that is the power of the cloud. When you have a lot of data, you need storage, and it should be cheap, it should be easily accessible. Next is big data analytics. When you have a large amount of data, that data is just there. I need some way to be able to access that data, remove information from that data, find patterns in that data. All that is big data analytics. Next is Internet of Things. Now you have all that data, but you can't expect everybody to go to the computer and access that data. That data should be accessible from anywhere. There may be a smart fridge, a smartphone, a smartwatch, a smart car. Any device should be able to access that. So that is IoT. Are these concepts very clear? And the last one is machine learning, which I will be focusing on today. So basically, it is just you're using cloud, big data, Internet of Things, augmented reality, whatever you're using, but you are strategically evolving. Suppose I develop one process like a cloud, the technology to access data. That cannot be redundant. It has to understand, okay, people from this place are accessing more, so let's keep their cloud database closer to them. It is learning strategically so that maximum people can use and get benefit. So that exactly is machine learning. The evolution of AI and ML. So it started a long time ago. I'll go through this fast. So it started with scientists wanting to create a human brain. So the human brain was very, very complex. They could not, construct it like how you construct a head or you construct a leg or teeth. Brain was too complex. So they started studying the brain and they understood the patterns in the brain and things like that. Then Alan Turing is a guy who is called the father of modern computer science. Do you all know who is the father of computer science? Computers? Not your father, father of the whole world. But anyway, it's okay. You don't know, right? Did you know? Please say the answer. So Charles Babbage is the father of computer science. But what he developed was something like a calculator which could do complex calculations. There was no algorithms, there were no mathematical procedures. So Alan Turing started with algorithms, like you give a step-by-step procedure and the computer can understand. Then John McCarthy, he said, let's have something called AI. Let's have a machine where they write an algorithm where the machine can work like a human. So John McCarthy is called the father of AI. Alan Turing is the father of modern computer science. Then a lot of new things came up, like time sharing systems. Time sharing systems are, you reserve every computer being expensive, you buy expensive memory, and each computer accesses that memory as and when they require. So that was one way in which the high computing power could reach more people. ML, neural networks, ARPANET was the first version of internet, which was across one community, a small community. So all these things came, but then 70s to 90s it is called AI winter, because although they had come up with all these technologies like neural networks and all these things, machine learning algorithms, they were not able to do very complex things because computation was expensive and memory was expensive. So there was an AI winter because people had ideas, but they had to give up on the ideas because the technology was not available. Then in the 90s came the internet, e-commerce, simple websites wherein you could just purchase something. Amazon had the first one, the first e-commerce websites for selling books. Social media also was, just starting with, small, like in a small place, something like how the founders of Facebook did. They started with a small portal in their college. So social media had just started. Then in 1997, Deep Blue was a computer which acted smartly for the first time by beating a chess grandmaster. You all know who he was? Yes? Who was the grandmaster who
Anand, Vishwanathan Anand.
Yes, Gary Kasparov. He defeated him, and that was the first time. In fact, there were 6 games they played, and the first game the computer lost. The second game the grandmaster lost, and then there were 3 games which were draws. And in the last game, the computer learned from 5 games. His strategies, his weaknesses, his strengths. And in the 6th game, the computer won. So with this was the boom that, okay, the AI can happen, we can do it. So people started exploring different options. And then, and also there was this idea of utility computing. What is utility computing? People were selling books on the computer, people were selling, phones on the computer. So somebody said, why don't we sell memory on the computer? Why don't we sell computing power? So a company called Salesforce started selling services. So selling services became an option in the late 90s. And then 2003 onwards, in 2003, AWS is the cloud of Amazon. So Amazon Web Services, for the first time, they created a platform which anybody in the world could access and get for whatever they wanted. The memory, how much they wanted, the compute power, how much they wanted, wherever they wanted to store, they could store. There were different security features and so on. And then towards 2006, 7, 8 and on, the Microsoft came with theirs, Google Cloud, all these other platforms came. But the first platform of cloud was which one? Which was the first platform of cloud?
AWS.
It was the Amazon Web Services. Okay? So now we spoke about learning. I want to ask you, what is learning? Learning is when you practice something, that is when you are learning. If you just write something on a book and you keep it on the shelf, that is not learning. I'll give you an example. How many of you here ride a bike? How many of you ride a cycle? At least, okay. Or cars? Any of these vehicles when you're starting to drive, if suddenly you have to press the brake and all, you get nervous. But as time goes and you get better and better and better at it, when you drive, you don't even have to think because your feet are already trained to press the brake. Even if you don't see Your hands are trained to press the horn. Even if you are dreaming, of course you should not dream, but even if by chance you are dreaming, you can dream because you are such a good driver that you have trained yourself that way. Sometimes you see a Ronaldo kicking or doing a bicycle kick or a back heel kick. So why can he do that? It's not that he has eyes behind his head, but his legs and his head can think because it is so well trained and he can push the ball into the net. It looks strange, but it's true. Similarly for your exams, if you all study and you know your meta well, you can just sit for the exam and your hand will think. You don't have to actually think what comes next. Your hand will just flow. So learning is very important. The more you look at it, the more you learn it, the better your mind gets trained. The better your mind gets trained, the more. But my aim is to explain to you what are these three forms of learning in simple layman language. So tomorrow if somebody asks you what are the three types of learning, then you all can tell. Okay, not say I don't know, I'm not heard of it, or things like that. So machine learning, there are three types of learning: supervised, unsupervised, or reinforcement learning. Simple analogy I give. Your baby brother, sister sees a glass of hot milk on a hot utensil on the table. So your mother says, don't touch that glass. But she wants to challenge, so she goes and she touches and her hand gets burned. Next day again she goes. Her mother says, don't touch. But still she's thinking, maybe today it's not so hot. Slowly she touches, but now she has learned if she does like that, her hand will get burned. She touches slowly, gets less burned. Then she says, okay, third day she doesn't touch it anymore. That would be a kind of learning through experience. You are learning from your experiences. So similar to supervised learning. She has taken the previous examples. An example where I touched and it was hot. An example where I touched lightly, still my hand got burned. So better not to touch. That is supervised learning. Unsupervised is, she has no way of storing that previous information. So there is no previous evidence which she is using. But when it is hot, when she takes a decision to touch, she puts it in one bucket. Decision not to touch, she puts it in another bucket. But the consequences of her actions are not stored. That is unsupervised. And the third is reinforcement. She touches and the mother gives her one slap and finished. So she will not do it again. So that is awards and punishment. The third is reinforcement. So is the difference between the three learning methods simple? Next slide. So supervised learning, you have a big table. You see you have a data set. Data set is where all your data is stored. So there are 1, 2, 3, 4. I don't know if you can see on the blue part. Those 1, 2, 3, 4 are bird, mammal, reptile, and fish. And here on the column, the blue column, those are all the features. So if the features are, there are feathers, and there is a neck, and there are legs, and it is in the air, then it is a bird. So based on those features, it is learning. So I am giving the model all the data, and based on that, it is learning. So it is supervised. I am telling him everything, and then he is learning. Examples are, so inductive learning is learning from experience. Inductive learning, learning from experience. Classification is, suppose I have two sets of, I have all students mixed up and I want to classify who are from Don Bosco, who are from Green Rosary. So to classify, I am putting a label of them. So by looking at the features, okay, she's a girl, she's wearing green uniform and all, she must be from Green Rosary. A boy, someone from Don Bosco. So that way, I am looking at the features and I am giving them a label. Classification, face recognition, these are all examples. Prediction. Prediction is an example of regression. I want to find the value. For example, I am buying a house in Loyola. A house in Loyola means Loyola has very good roads, it has very good garbage treatment plants, it has 3 ministers are there, and it's a very good property. So all those are the features. Based on those features, I can predict the price of that house. Now it is not a fixed label. In the first case, I had only 2 labels, maybe 10 labels. Now it is infinite. It can be 1 lakh, it can be 1 lakh 10 rupees, it can be 3 lakhs, it can be 40 lakhs. So that is regression. The labels are not fixed. You are directly giving some value. Is the difference between regression and classification simple? So prediction is you are predicting the price on something, predicting the probability that an earthquake learning is, I just have a big set of data and the algorithm learns the features, and all those who are similar, he puts them in one place, and all those who are similar, he puts them in another place. Okay, so that is clustering. I'm not going to the theoretical, there's a lot of algorithms for clustering. Clustering is I'm putting them based on their features, you are learning their things, seeing the features, putting them here. If the features are very different of these two people, that means he's on a different cluster. That is clustering. Applications. The supermarket or whatever, he's not interested in your name and who you are and everything. He's just interested in buying patterns. So people who buy this kind of things, they are in this cluster. People who buy this kind of things are in that cluster. Health, grouping objects based on value, type. Similarly, how there I'm using it to find the price. Now I'm putting the features and I'm saying, okay, these are similar features, they will be in the high price cluster, these will be in the low price cluster. Of course, that name, high price and low price is not there. I'm just separating them into two clusters. Third is help making predictions, like all these things, the place is close to some volcanic area or something, so it's prone to earthquakes. So all those houses and those features, that cluster is prone to earthquakes. Research area is finding the difference between twins. So twins, there is hardly any difference between them. Okay, there is minimal difference. But how can a computer know the difference between twins? So I would study how does the mother of the twins recognize the twins? How does the mother recognize? One, she's very familiar because she's looking at them every day. If you don't see them every day, you cannot recognize. Second is she knows something. Okay, that one's lips are like this, that one has a mole. She knows some critical feature. So I should have a machine which learns these critical features more. If that person has a big nose and both the twins have big noses, then the machine may get trained to learn about the big nose, which is not beneficial for actual recognition because both have got the same nose. But you should be able to recognize that difference, which may be very subtle. So this is called fine grained. So now you can imagine the level where AI has reached, it is no longer classifying a dog and a cat. It is now a husky and a malamute. Like the dogs which look similar, classifying, or a dog and a wolf. A dog who is in the snow may get confused for a wolf in the snow because dogs are normally trained with images in the house. But a dog which is in the snow may get confused with a wolf. So this level of intelligence can be achieved with deep learning. And learn in three-dimensional space, which is used in augmented reality and those applications. So deep learning has made it possible because compute power is easily available. And for my research work, I had started somewhere in 2016-17 where I did not have access to high compute power. So I remember I had to invest and buy a very expensive laptop which had a graphics card to do this processing and quick multiplication of the matrices. But towards 2018, it was really a waste of money because today you have tools like Google Colab and all where you can directly run your code online, and I have bought a computer which is like 8 GB, which was great at that time, and today I can get 10 GB or 30 TB for very minimal charges and even free. So this is the benefit. So with zero money in your pocket, you can develop things and make things happen just by being interested, be innovative, be creative. So next slide. These are just simply small videos which make life easier. You must have seen sometimes the security person, he has to monitor multiple screens. So if the screens are automatically getting monitored and he just gets an alert when some anomaly takes place, his work becomes easier. So suppose you are, people without uniform are not allowed in the campus. The security guard doesn't have to search all the cameras. He will just, if he detects somebody without the uniform, and he will tell him, okay, so and so person has entered to this gate. ID card, you can use it. The next can cover their faces. So these are apps where you can check, some third party can check, as well as you yourself can check that you are socially distant from the others. Okay, these are some slides, 2 slides about our college. There's a lot of this research work going on at PCC. So we have 4 programs: mechanical, electronics and computer engineering, computer and information technology. This is of course for the science students who are interested. And we have SIBA. SIBA is a place where there are entrepreneurs. So SIBA is a center for incubation. Anybody can start a business, and SIBA gives you wherein you have to submit your business idea. They will help you to make your business idea into reality. So SIBA is the Center for Incubation. The first one in Goa was at our campus. And of course, IIC, I don't know if higher secondaries will have Institution Innovation Council. So they have a lot of competition like hackathons and things. So we are permanent members of that because many of our students have performed very well in these competitions. So next slide. The programs offered, now from last year, we have 4 branches I told you. So if you are from computer engineering, if you join computer engineering, you can you get a BE in computer engineering with honors in, oh sorry, there's a mistake here. Computer engineering is AI, ML and data science. And mechanical engineering is smart manufacturing and energy. So there's a swap there. Again, smart manufacturing is again automation to do with AI and ML itself. So any course, now suppose a mechanical engineering student does an honors degree in smart manufacturing, he can also take up a minor degree in any of the other branches. So now we are moving in a place where everything is multidisciplinary. So there was a time wherein, to change the car tire, I needed a mechanic or somebody who's an expert at changing the tire. But today the software will tell you whether the wheel is aligned properly and things like that. So there's a lot of automation in mechanical itself. So if you are a mechanical engineer who has a minor degree in data science, ML, you will be definitely preferred in the manufacturing companies. If you are in the software, again, you will get more exposed to creating these technologies. Next slide. Okay, this is just some of the events. And my last slide is thank you. And it is, the old model was the big crush the small. So in the past, somebody had a lot of money to start a business and buy the place. Evolved is, if you're fast, if you're quick to develop something which nobody has, you have made it big. But the new one is, you have to be innovative. You have to be quick and fast and you can beat the rest if you're innovative. The moment you see a problem, you think what would be the solution. It can be something big, it can be something small. So thank you. Do you have any questions? No? Yes? I think you want to know what is energy engineering? What is it? What do you think it is? So can you go to the previous slide? What is energy engineering? Today, we are too young for Instagram. Generally speaking, I don't feel you are too young. You need to know these things so that you will know the weaknesses and tomorrow you can create something better. So you have to be exposed to a lot. Never feel that something is not important for you because everything you learn will be applied somewhere or the other. So never feel something is not important. Irrespective of the field you are in, as I told you, even if you are a lawyer, you want to make your judgments more efficient. If you are a doctor, like I tell my husband, if I go to a doctor, the doctor checks you with the stethoscope, he gets the results on everything on the sheet. And anyone can be a doctor because actually the work is done by the engineer. Correct? The work is done by the engineer. Anybody can be a doctor. That was, just there's always this thing about professionals. But that's not true because the doctor has 2 things. Besides that knowledge which he's getting, he also has real life experience. So that is why a machine cannot replace a human being. He can only make that doctor's work easier. He can make the doctor remember experiences faster. But it cannot replace the doctor. I can go to Google and get an idea, but I cannot take the medicine prescribed by Google. For that, I have to go to the doctor. The doctor knows your history, he knows the history of that disease, he knows everything. Similarly with lawyers, I can go to the internet, find some judgment. But whether that judgment can be applied to this case, that I will know based on experience. What are the things that can go wrong? So, irrespective of what you're doing, my point is whether you're doing commerce, or you're doing some finance consulting, or you're in arts and you're writing poetry and books, or in science and you're developing the next Tesla, irrespective of what you're doing, the way the mind thinks, all will be thinking the same way. You're basically trying to make life better and finding solutions to problems. And AI, with the new APIs and all, it is making it accessible to everyone. So with your idea, you can either build on your own or pay somebody, but at least you should be aware that this thing is possible to be done. Is that clear?
I would like to thank Professor Razia for her session today on AI and ML for digital transformation. Thank you, ma'am, for sharing your experience and your expertise in a very, very simple and interesting manner for the better understanding of our students. Thank you for your time, thank you for your expertise, thank you for all that you've done for Don Bosco today. May God bless you.
I work with it. But another example, now there is something called perception, wherein the computer understands the person's mood based on any type of mistakes or based on short messages or based on closing by mistake, opening your browser. So based on that, it perceives your state of mind. Now, perceiving a state of mind, it could be that you are upset and stressed, or it could be because you are excited, but that is again a fine thing. It's very difficult for them to classify. So generally what they do in AI, a general problem would be classification. All in this, all those who type fast and make mistakes like this bucket, all those who type slow, but in that bucket there can be more types of So for me, I version to their larger problem. They will give you a team for your larger problem. You don't have to do it. But they want your intelligence. They want you to be smart enough to think of that idea. And this only comes from reading. Like I like football, so I read about every tournament, everything which is going on. So you ask me about any player, where he's transferred, I just know that information because it's my passion. Similarly, if you have a passion, you know what is the weakness, what is the strength. So you can think of ideas in that area. You may not have a passion, your passion may be coding. So you can take ideas from another area also. So this is digital transformation, they are trying to make everything software.
But
In a few years,
everything software and there's AI, but it is very costly.
no, it's not. It's costly now because they're just coming.
Yeah.
The Alexa series is coming. Tomorrow, if you make Alexa in your house, why will you buy the Alexa?
Because I have been working on a system. I was working on a system and I searched it on net. So there was this that browser alert system, and they were using AI for it. And like how you showed it on the screen, they were actually using the camera, and there was this lines and all done by the engineer students.
Yeah.
But the price was very costly.
Of the kit, device you're talking about, right?
Yeah.
But do you know kit? It just cost you about 750 rupees. The college will give you those kits because they're a part of your curriculum. We have those kits which you are using to learn. You cannot take them home. But if you want, you can buy your own kit and make that kit yourself. And if your idea is so good, you can patent it and some company will buy it for you from millions of rupees. That is why in a profession like where you're developing apps and software, by the age of 25 you can retire. If you develop something so good, when you make your money, you can retire and become a philosopher. So it's like that. Whereas in some other profession, it may be that they learn and the experience they get. But for our engineering students, that day one, that fresh knowledge which he has, nobody else has.